Alright, well there we go. I think we are all set. Now the question is whether or not I want this music to be playing or not. Let's see here. I kinda like the music. I hope I can hear myself. Um, let's see here. Let's go ahead and start this. Let's see here. So, there we go. Just transition. Hard transition. Uh, I'll keep the music for now to help me just for a little bit. Just for a little bit. Uh, all right. Let's make sure everything is looking good in the background. See, so currently I'm trying something new with the stream, where I'm streaming to Twitch, streaming to YouTube, and streaming to watchmework.com. So hopefully this goes well. Let's see here. So I'm just trying to make sure I can see all the chats. You know, as much as I like this music, I'm probably just gonna have to pause it. It's slightly distracting. There we go. All right. So there we go. We're all set. So where I last left off for creating this game is I was trying to make some believable rope physics, something like that, where something not like that, never mind, but something that would keep it a certain distance away from whatever. What I have creating here, or what I'm using here, is a line renderer right here. This is a line renderer, and every physics update is calculating the points of these of the tethered rope here. So this is the anchor. It's going to be staying still, and this is the other part. This is the part that can be moving. This is the player actually, and I am hoping to make it so that rope, so that way a player can actually swing from this, and that's pretty much it, I think. What I hope is to be able to have it so that the player can swing from something right here. I have some basic movement controls which don't seem to be quite working right now. Let's see, I don't need this right now, so I'm just gonna put that right there. Let's see here. If I go here, yeah, something's not quite right. I'm not sure why. Let me see. Just gotta check to see if my input was just stuck or is it just moving. Nope, it's just moving. All right. So where I last left off the other day, or actually I think it was earlier today. Actually, what time is it? 10:17. Yeah, earlier today is that I was doing a fixed update and have the anchor position, the rope positions, also having the transform always be in the center of what the line renderer is. So by using some math, and let's see here, maybe I can do a little cleaning up right here. Uh, this spring direction is exactly the same as this rope direction. It's just that I didn't update the variables. Separation, I moved it up here. Positions is where I set the positions. Mathematically calculate the positions here. So there's that. Let's see here. What else do we got? We have something else. Give me a quick second right here while I do this. Okay. So we have anchor position, rope that get position. Now I don't need that anymore because the idea is that the anchor is going to be staying still. So I'm gonna keep it like that. You know, I'm gonna test my audio. I want to hear, make sure it's working right. Give me a second. You're gonna hear this here. So this is the anchor. It's gonna be. All right, sounds good. All right, sounds good. And maybe if some people join later, they can let me know if it's something sounds weird or not. Let's see here. Let's just go ahead and figure out where I'm at. Okay, so this is what I have so far. So transform that position anchor. So this actually just this sets the rope transform to in between anchor and tethered object. So there we go. So I'm just gonna add a little bit right there so I can keep this organized. Let's see here. This right here, the rope direction is a normalized vector pointing from the anchor to the tethered object. So it's array. In a way, it's a kind of, well, I'm going to be using it as array, but it's just a normalized vector. Here is the distance from the anchor and the tethered object. Let's see this. I'm gonna try to start commenting on my code so that way I can quickly reference it right here as well. And maybe have people also understand what they're doing if they're reading or looking at the code. All right. Rope set positions. Sets the points in the line. Oh, looks like I got paired with somebody. Interesting. I honestly don't know how that works with Watch Me Work, but we'll just say hello. Let's see here. Oh, it's also, let's see here. Let me go ahead and add this here to the description. Let's see here. Title. Is there a description I can add here, I wonder? Probably not. I can just keep it into the chat, so it's saying right here. There. Like that's the website that potentially, and there's my self replying to myself, silly bot. Let's see here. So sounds good. Where was I? Sets the ropes transform between the anchor and the tether object. Yes, I remember that. Sets the points. Yes, sets the points in the line renderer that no sets the points. Sets the points that from which there we go. Okay, I've got my English. From which the line renderer will be drawn. Easy. Okay, so all this code up here is working good. Excuse me. So that works. So we have this. So now the problem is to kind of have some kind of realistic rope physics, but not actual rope physics. If anything, it's supposed to be like swinging physics. So first thing I would need to do is to have the player be always a fixed distance away or can be closer. So they can they can see I could either make it so that way they can fall down and be closer to it, or they can always be a set distance away. Yeah, okay, I'm gonna go ahead and do it to make sure that they're not always a set distance away, but they have a maximum distance they can be away from the anchor. So let's go ahead and take a look at this. Tethered. How would I go at this? So this is kind of what I did beforehand. Is I did I checked the separation and I checked the length of the rope, and if the length of the rope is less than the separation, so if they're further away from each other, then I got its rigid body. Let's see here. I probably might want to fix this. So whatever. Rigid body. No, I want to go ahead and change this over here. So we're going to make this a different variable. We're just going to have body2, or how about we just name this tethered body? Tethered body. No one's been body. No, that's what I was saying. No one's been bothered by a tethered body. I don't know if that makes any sense. Let's see right here. So there's that. And tethered body is going to be gotten, I guess the right way, when the script awakes. So there's that. All right. Now, let's see here. Gotta fix this. The reason why I wanted to set the variable once, so that way it doesn't waste computation by having to get the component every single time it updates a frame. Just get it once and done. That's the idea anyway. Okay. So it's funny because I just think I'm going to delete that, because sometimes when I have trouble figuring out what I'm trying to do or what to do or how to get what I have already working, then I just delete everything and start from there. So let's see here. If separation is greater than length, so if the distance is too much, then I have to do two things. So I have to do, one thing I have to do is stop stop player gravity, or maybe rather, or adjust it. Okay, adjust it. Keep player at, or maybe around the max distance. And let me see here. So let's see here. We could calculate what the actual distance here would be. Let's see here. What is this? Anyway, I don't know, I'm just looking at the website real quick. If you want to see it real quick, this is basically what it looks like. It's kind of interesting. Um, there's my stream right there, showing a stream within a stream within a stream, probably. There we go. I was waiting for that to happen. And there's the guy who got paired with. Not sure if he's here. So I'm just gonna say, oh, what am I doing? I'm gonna say a quick hello, and then might be nice. Be nice to a neighbor. Why, right? If I'm assuming he's there because basically he's through, you set up through YouTube, but that's neither here or there. But that's where was I? Yes. Okay. So what I'm first thing I'm gonna try to do is I'm going to calculate uh the furthest position the player should be. Okay. So that's going to be really easy because all I need to do is I already have the rope direction, and that's going to be times the length. So since, because now this is the normalized vector, it's pointing in the direction of where it has a vector pointing to direction. So if I multiply by the length, it's going to be pointing in that direction. So this is where the player should be. So I could potentially just have the player, tethered body. Maybe I can put move position right here. Maybe I can just try that move position. So that way And we'll see how that works. We'll see how that works. Where's Unity? Yeah. Because that would be pretty simple if that just fixed our problems, but I think I'm going to be falling down. Ooh. I keep getting pushed to this position. I'm not sure why. That's interesting. Oh, okay, so I'm just gonna put, yeah, I'm just gonna go ahead and stop that part. I think that's what's causing it. No, it's not. What's causing this? This is really weird. I don't think, yeah, my key shouldn't be stuck. Okay, so that being the case, what if I just copy the, comment that out real quick, and we'll see how this works out. It should just fall straight down. Bam. All right. Oh, I know a problem as well. Not sure if that's will fix it, but I also forgot one more thing. I also need to have the starting point. So we're gonna have the uh, anchor dot position, and we're gonna add that to this right here. And that should put us in the right spot. And I think, let's see here. I think I can also do a debug as well. Debug dot draw draw a line. Draws a line from start. Let's see. We're gonna go ahead and just make this draw a ray because that's kind of what I'm. Or actually, no. If I just make this times this by the length instead. Let's see. Transform that position. How about with this actually? We're gonna do this anchor dot position. And then transform that position plus rope direction, or anchor that position plus rope direction. There we go. So we're gonna have this the same way. So that line should start out here and go to the player, or where the player should be, which also fixed it. There we go. Let's see here. So that's one thing right there. But the problem is now the player cannot move because I'm forcibly setting their position to this position right here. So what I should do is that I should move the position, I think, on the y-axis. So I'm going to go ahead and then do vector 3 dot, well, actually no, not up, because up is, well, up can work. Let's see here. All right, yeah, we're just going to do vector 3 dot right times whatever results from here. Oh, this is a vector 2. Whoops, that's my bad. There we go. So I'm thinking what that will do is that will force the Y position to be where it's supposed to be, which is interesting, but allow the X to move, which is what happened, but just not quite where I want it to be. Let's see here. With that being the case, what we're gonna go ahead and do is, for now, I'm gonna try something a little bit different. Let's see here. I want to try to see if I can do something else I can draw easily. Not quite what I want. So visible is debug log error log format. Unity logger. Okay. So the problem is I needed to apply some kind of physics here. Okay, so let's see here. Let's think about this logically so far. So we have a circle, uh, or we have the rope, which has a certain length, which is the radius of a circle. Um, we could potentially maybe use a the formula for a circle to calculate what the y would be based on the x-axis. So let's see. Let's look that up real quick. Let's see here. Go ahead and do the, whoops, and give me a second right here. Why is this not working? Oh, okay, I see. Calculate the position of y on a circle. Points in a circle. Okay, let's go ahead and take a look at stack trace real quick. A point at angle theta on which circle whose center is x0 or an x coordinate and y coordinate, and whose radius is r, is x0 plus r cosine theta y0 plus r sine theta. Now choose theta values every space between 0 and 2 pi. The classical equation is value 3.15 pi. Okay. So I guess that could make sense. Let me see if there's anything. Is it trigonometry? Calculate x, y position in a circle every n degrees. Uh, Inverse wise, probably looking right. Looking interesting. Let's see what else here. So that's trigonometry. Equation of a circle. I think that could be kind of what I'm looking for. A circle is a set of all points in a plane in a given distance called the radius from a given point called the center. A line segment connecting 2 points on a circle and going through the center is called a diameter of a circle. Assume that x and y are coordinates of the points in the circle shown. The center is hk and the radius is r. hk is the center. Okay. Use the distance form to find the equation for a circle. Substitute this right here. Substitute x1 and y2 with hk, x2 squared, and d radius squared. Instead, the equation of a circle with the center of hk and the radius units is r, x2 minus yk equals r2 squared. So, if this is the equation of a circle, okay, that makes sense. So let me go ahead and write that down. Let me go ahead. I think I can already see what I'm going to be doing with this right here. Let's see here. Let me go ahead and clean these up real quick. Do I need this in here anymore? Nope. Close, close. Create another new. Open Notepad. Let's see here. So this is the equation of a circle. So what I want to do, if I want to go ahead and single out y, what I can do is first, if I subtract this whole side right here first, or actually no, if I take the square root of both sides first, that leaves us with the equation x minus h. No, I don't think that's quite right, because if I square root both sides, I have to plus. Yeah, not quite what I'm looking for. So what I'm going to head and do instead is I'm going to go ahead and just kind of subtract it in a way. So I'm going to get x minus h squared minus r squared equals y minus uh, y minus k squared. So now if I take the square root of both sides, we have, let me see here, this right here, minus 2 to the square root 0.5 equals y minus k. So then now all I have to do is, y minus k, copy that line. All I need to do is then add k to the other side, and that should be how I can calculate y. So let's see here. Do I need this anymore? Probably not. So we'll get our equation real quick. Right here. We're going to go ahead and do this. Using the formula for a circle calculates what the y-axis should be, what the y position should be. So there's that here. And the original formula is this. Circle formula solving for y Alright, so now we just gotta go ahead and try this again. Let's see here. So first we have to have the center of the circle. We can probably have that. We have h is gonna be the x coordinate of the circle, k is gonna be the y coordinate of the circle. So we just gotta go ahead and do this. Let's see. Float y equals. We're gonna do k first. We're gonna make it kind of easier. We're gonna go ahead and do not transform. Anchor dot position dot y plus here. We have to first get the position of the player, which x has to also be the max distance. So let's go ahead and move this. We're just going to go ahead and put this right here. Float x equals that same thing we had a bit earlier. So let me go ahead and I don't need this right here. Basically whatever is calculated from this right here, which is anchor dot position plus rope direction times the length. So there is that. We're going to go ahead and put this into a parentheses right here. And we're going to go ahead and get the x. So this is take into account the player's position, yes, and then calculates what the x should be based on the length of the rope. Now we can go ahead and plug it into here where we get k plus x plus anchor dot position dot y, no x. So we're going to have to get that squared. We're going to have to square that. And we need the radius too here as well. So minus the length squared. And then we have to have, that's it. That's basically it. Now I have to actually add a few things here. So math f, the power, there we go. Okay, float. Here, anchor x minus that right here to the power of 2 Let's see here. That's one part of it. There's an argument that corresponds with the power P when float 2F. Let's go ahead and see this for now. What is the problem here? Float, pow. Ah, there's the problem. There you go. Okay, that's the power right here. That's this part right here. Now we're going to need to do the same thing, except that the, let's see here. Just want to check this through real quick. Oh, he responded to us. Cool. Now where was I at? Let's see here. So we got that part right there. Now we got to go ahead and do the same thing with the length. Let's see, minus mathpow 2f. There we go. Now we have to do that once more, except we're going to put 0.5 f here, and then we're going to add this mathpow over here. And ka-chow. I'm missing something here, aren't I? Yes, no, there you go. All right, let's go ahead and check our work. So x minus h, x minus anchor position x. So there we go. H is the center of the x. There you go. To the power of 2. Bam, that's done. Minus length squared, or the radius squared, length 2f. Perfect. And then all of that together to the power of 0.5, or the square root of. Let's see here. So there's that. And then we have k plus at the beginning right here. I guess I can, now that I have that figured out, I can just go ahead and add it over here. And that should give us the point we need our y to be at. So what I need to do is I'm going to go ahead and put the tethered body dot velocity times equals vector 2 dot right. So we're going to get rid of all the falling. All the falling potentially. Oof, I'm really interested right here. What should I do? Actually, no, I should have it do two things. I should have it calculate x based on whether there's actually any velocity or power being pushed into x. I think, right? That sounds about right. Because the script itself shouldn't be applying any x velocity. So what I'm going to go ahead and do then is put float x if tethered body dot velocity is, oof, there's a problem though, because it's, since this is a float, it's not gonna be kind of close. Let's see here. All right, then what we can do potentially then instead is just try not to touch the y velocity at all and just adjust the position. So we're gonna go ahead and do that. And we're going to set the body tethered body dot position. Oh wait, what am I trying to do? I'm actually just get the tethered dot position equals let's see here. I could just create a new vector, but this feels a little bit. All right, new vector 3 And we're going to go ahead and put x, y, and I assume 0. Or we can just keep this tethered position, not z. Or z. Z, not z, because I'm the doctor, not z doctor. Alright, so that, oops, well, that should work. We'll see how this looks. Alright, well, that's cool. That's great. Player is not valid. What do you mean? Player is definitely valid. Let's see here. Transform position assigned attempt from 4-player is not valid. Input position 0.5, not a number, 0.1. Okay. That would probably have been a good thing to test first to see what the actual values were. We're going to go ahead and do x plus this plus y. Oh, and semicolon. Wait for it to update, and we'll just watch the values. We already know it's going to be not a number, but it's always not a number. Answer is yes. Okay, so let's see. If I move it here. Alright. So there's that. Oh, whoops. 3.14. I'm pretty sure that's supposed to always be 3 at at most. Let's see here. Yeah, see, it's falling, right? Okay. Uh, let's see here. Actually, what I'm gonna also do is we're gonna set this the anchor position to not be multiplied by the separation, but actually the length itself. Uh, divided by 2. So that way it should always stay where it is the center of what it should be rendered. So there we go. There we go. There we go. That seems about right. Not anymore. The values, I'm not sure about why the values are what they are. Let me think here. What do we have as the values? How are we calculating x? X equals the anchor position plus rope direction times the length. Or we're going to do this as well. Change your length to math dot min, and we're going to take the separation and the length. Does that make any sense? I think so, yeah. So rope direction is there, anchor position. I'm trying to think right now too. It would potentially automatically, wouldn't it also automatically have the right position based on this right here? Let's go ahead and make this right here. Make this its own vector. Vector 2 rope vector. Because honestly, like, it would have been pretty cool to have to use all this math, but potentially I don't need it. And give me a second right here. Oh, sorry about that. Had a sneeze, and nobody wants to hear that. Okay. So rope vector, we're going to check to see what x equals, and we're also going to try to see what y equals. Let's see here. Yeah, so that's pretty much doing a work for me because what I was doing is so 2.8, 2.9, 0.7. So I assume that that's supposed to equal somewhere around 3 or the hypotenuse of that triangle with that would be equal to 3. That's what I'm assuming. Which, now I think about it, I probably could have used Pythagorean's theorem if I really wanted to calculate this, but I think this actually does it more simply. Let's see here. The only problem, potentially, let's see here. Well, actually, that's not even a thought, because it's based on how the player moves. So if the player falls, how about we try this? We'll just try this. Since the other end of the point should be where the player is at, we're just going to go ahead and now that I think about it, that's kind of weird that I'm multiplying it like this right now because this is only run when this separation is greater than. Maybe I'll also run it when it's less than, because otherwise I don't think I actually need the min, because it's always going to be a number that is higher than length. Let's see here. So there's that. Uh, new position. Or can I just also just call it the rope vector? There we go. Well, here's hoping that that was a simple enough solution to my problem by just fixing a few things. So, oh, that's right. I was having a similar problem where it just kept forcing me down, and I don't understand why. Let's see. Why is that? Rope vector. This would be the point, anchor point right here. Position, direction. Let's go ahead and get rid of this too. Length. So there's that. But I think the problem was that Y kept pulling me down, but I don't understand why it keeps it wouldn't move me to the right place. Or how I can just do, I guess I could do tethered body, move to position, and we can just pass the rope vector. And perhaps that works. We'll see. And that's the problem right now. So if I try to move side to side still, it's not going to let me. Okay. So here's what we're going to go ahead and do. If tethered body dot velocity dot x is not equal to 0, God, no, I know what it's gonna do. It's gonna be like, oh, this is you're moving. Well, actually, no. It should be always being set to 0 when, yeah, it should always be set to 0 by my player movement script. It's not equal to 0. Then we're gonna do this. We're gonna go ahead and change the rope vector to an empty parameter right here. And we're gonna go ahead and move this to right here. Get rid of this. So this is assuming that this is originally assuming that the velocity of x equals 0. So we're going to go ahead and get rid of this, get rid of this, and add an else statement. And we're going to add one more just to clean it up. then format it. Perfect. Let's see here. So if it's not equal to x, then what we need to do is to calculate what the y be, assuming that it moves over to the x. Let's see here. Oh, whoops. Where would I be now? What is next up? Let me just check to see that everything is looking good. Streams are still going. This is good. That is good. So there's that. Where am I at now? So if the x is moving a certain way, then the position it would be dependent on its mass. Let's see here. The position it would be then would be what's the equation for movement? A trajectory of object? No. So it would be a. So I know it would be distance, velocity, and mass. So let's check this out. Because what I can do, if I know that you can find, if you can find the mass from the distance and velocity or something like that, then I think I should be able to use the other equation to calculate the distance based on its velocity and mass. Let me go ahead and just take a look at this real quick. Force equals mass divided by 2 times velocity squared. Is that right? Let's look at this. If you do not have mass balance, we object balance scale. No, that's not what I'm looking for. I see how to calculate velocity from force and distance. Yeah. Let's see here. So the substitute the measurement for force, distance, and mass into the equation. If the force is 2 newtons and the distance, actually, let's see here. Force equals the mass divided by 2 equals this right here. So measure it for force, distance, and mass into the equation. If force, okay, how about this? Let's calculate force. Calculate force. Force equals mass times acceleration. And acceleration, calculate acceleration. Let's see, how do you, what is the formula for acceleration? Acceleration formula is something. Velocity, let's see here. Final velocity, initial velocity, time. Let's see here. Equals change of velocity over time. That's acceleration, yeah. Okay, I get it. That makes sense. And what about this? I think velocity is the measurement of speed, right? In a given direction. Okay, so that's good. I got that. So how do I check the force? Okay, so let's see here. So we know the mass of object. We know the velocity. So we should be able to calculate the force based on that. But is that what we're trying to do? We're not trying to find. We're trying to calculate what the position would be. So let's work backwards then. for acceleration formula. We know, let's see here, that we know we have the force net equals mass times acceleration. So if we know what force is and we know what the mass is, then we can find out what the acceleration is. And then change in velocity over time. We have the velocity over the amount of time. And we can check the amount of time using time.delta, so then we have the change in velocity. Let's see. I don't think this is quite what I'm looking for. Calculate position of position from velocity. Position calculus. Ooh. Lovely math. If we have a vector AB and a perpendicular vector BA, then the perpendicular vector 3, 4. This is not what I'm looking for. Distance, displacement, and position. That's what I'm looking for. Distance, Honeybee makes several trips. Total distance, 700 feet. Displacement, 100 feet. Position, several. Too many words. And I don't want to have to read through it quite yet while I'm streaming. Oh, looks like I am the only one here now. How sad. Let's see. Distance, position. How do I get the velocity? Distance, velocity, and mass. Then we're going to find a speed from distance and the math. Let's see here. Actually, let me see. Let's check another more thing, because what is speed? Well, then I guess because I would need a unit. I don't have what I'm looking for. Velocity time graph. Sure, we'll look at this real quick. Give me a second. I'll go ahead and just unmute the site.
Please visit our website at www.
Oh, is there just no time? Sound?
Hey everyone, we're back to talk about graphs of motion again. This time we have a velocity time graph, and it says determine the total change as rearranging it algebraically.
Determine the velocity change position by the velocity time graph below. Velocity equals, I'm assuming D is the position? What is D?
Algebraically, and writing it as velocity.
Yeah, so that would be velocity times time.
Also realize.
Oh, that's right. I remember this in, I think, algebra. Distance equals velocity times time. So, with that in mind, what? Let's see here. Let's see here. Then I could potentially calculate what the change in velocity would be based on the velocity of the force. Times length. Alright, let me try this instead. I'm going to first set this to the default value. Then, if there's movement, we're going to go ahead and plus equal a vector 2.right times the velocity times time.delta time So that way it would move a certain position way from X or move away. I don't think we need this for now. Let's see here. Okay, so now it should, if I'm not mistaken, move with it. Yeah, okay, so it moves with it, which is what I'm looking for. A little bit, but the problem is now is that it's not moving. The Y's gravity is being affected. So it's kind of what I want. Let me see here. So maybe what I can also do is that the resting position would be the actually, let's see here. Um ooh, I have something. I have an idea. So this is gonna be a multi-parter. The first part is to calculate what the bottom of the arc is, the bottom of the circle, or the furthest length, the furthest away from the bottom of the circle is. So let's go ahead and we'll need this right here. But instead, we're going to need to do this. Vector 3 dot point. See a down point. What's it called? Is there something called? What's the arc of a circle called, or the topmost part? What is the topmost arc of a circle called? I'm assuming that there's a name for it. Alright, we're just going to go ahead and call it the resting arc. The restful arc, resting? Yeah. Resting arc equals, let's see here. We would need a, no, actually, let's make this a vector 2. And then we're going to make this vector 2 dot down times length. So there we go. That's what it's going to be. Then next, that's the first step. So this is where the player would always be trying to be dragged down to. Let's see here. And maybe also what I can do is just simulate the physics myself by making this ridge body here kinamic. And or I can make it dynamic and just freeze the Y position so the X can still be moved by forces. That's kind of what I think I'm looking for. Let's see. Let's think. Clear all this. Oh boy. Okay, let me just finish my thought first and then we can figure out if we have a better way of doing it. Alright, so this is the length. What we're gonna go ahead and do is then we're gonna do this. I'm trying to think right now, what's in here, I think. tethered body dot move position. That moves that to the position, or we can add a force to that position. How would that make sense? Because what I was thinking was that if I can use like a lerp 2. Oh wait, yeah, actually no, that works. That works. Move position, and then we're gonna go have vector 2 dot lerp by t. Linearly interpolates between vectors by a and b by t. Float time. And we're gonna go ahead and make it from the resting arc and the player's current position. So that would be tethered body position. Then we're gonna have the resting arc. Then we're going to have time dot delta time. And then we're gonna go ahead and just return. We're gonna ignore all this other code that I have right here. And just to see how that looks. So I think the problem is that it's not actually this point, it's actually the wrong point, which is no bueno, no good. Let's see here. So let's make this up potentially then. Yeah. Huh. Well, I think I'm missing something. Oh, I know. This part right here actually. Anchor dot position plus vector 2 dot up the length. I think that's right. I think that's what I'm trying to do. Rope direction. Let's see here. Times the rope direction times the length. Ooh, no, that's not quite right. That's not quite right at all. We need to make this vector 2 dot up, or we can just make the vector 3 dot up. So that way we have started the position. We got a normalized vector, the 1, and it's going to go out towards the length, farthest point down, and then it's going to add this anchor point, so that way it's heading to the right position, or it's based on the anchor itself. And oh, that reminds me, I actually do need to make this down as well, so that way we know what direction we're looking for. Let's try this again. See, there you go. So now it's going to be continuously trying to lerp to this position. Let's see here. But that keeps the x-axis there. No, it's making the x-axis there. So what I would also need to do is tethered body. We're gonna have to do this. So otherwise, else we're gonna try this. Let's see here. Tethered body dot velocity times equal vector 2 dot right. So we're gonna get rid of its falling. And that should let me swing. Oh, actually, we gotta make this equal to 0, and then the other way around. Yes, that's kind of what I'm looking for. We're gonna actually, so we gotta do another thing. So we gotta get rid of the falling. Then we need to let's see here. Change the elevation depending on, or just do this right here. Let's see here. Rope vector. Do I need this right here? Rope vector equals rope vector. Oh, I read that twice. Anchor position plus rope direction times length. Let's go ahead and do this. And we're going to change this to rope vector to rope end equals anchor position plus rope direction times rope length. So we get rid of that. We're going to add tethered body dot. Let's see here. Position equals. So we know the Y should be rope end here. Or I can just do that. Yeah, I think that's kind of what I'm looking for. So it should let me move this around. There we go. So it's kind of what I want. Really close. The problem is too that the lerping, it looks really weird. Maybe instead of that, what we can do is just change it from the resting arc. Instead of that, we can just rope end, get the velocity. We're gonna keep the velocity the second the same. Let's see here. Body that position equals rope end. So maybe something like that. Okay. So it's working a bit better. Whoosh. Let's see here. So that's kind of what I'm looking for, except that that's definitely not how a rope works. And also when it's at rest, it just goes bam. It just goes like that. Let's see here. Let's see here. What is... Oh, there's an equation actually. I think that will work here. Unity equations. Unity equations. that's probably not what I'm looking for. Give me a second. I know there's a link. I think I copied the link. I'm gonna go ahead and do this real quick then. Unity. I think I was looking at it yesterday. Here, let's see. Here it is, right here. So there. Sure. I think Sinju Snurp is what I'm looking for. So that way, as it gets closer and closer to the end, I make the velocity less and less. That's what I'm kind of thinking. So the method will interpolate while easing around the end when the value is near 1. Oh, that's actually probably what I could do. Sine erp. We could just try that too. And get rid of this here. Sin. What was the... Did I really get rid of it? No, I should. It should be here still. Yeah. Snurp. Snurp, snurp. Snurp, snurp. I don't know. That reminds me of Newt, Newt. Math F. That's sin. Erp. P. Errol. No, not what I'm looking for. Sine. Find snippet provides function number C usage of individual information. I'm trying to use sine. Let's see here. Unity. Snurp. I don't think they have. Oh, here it is. Let's see. Sine erp. Float t current time, warp time. Alright, so maybe not because I don't have a certain amount of time. I want it to just go there. Let's see here. Okay. So this is not quite what I'm looking for. Let's see here. So there's a distance. Oh wait. Maybe I can actually do this. Rope end, but the velocity is going to be times equal to, let me see here, or would it be plus equal? Times equal to the right. So if y is equal, so this is x is equal to 0, then I shouldn't have to worry about the x. So then we can do, instead of multiplying by that, we can multiply by a, here, vector 2 dot inverse, was it inverse? And not inverse, was it vector 2 or was it vector 3? No, it wasn't that at all. Maybe it was math F. Inverse warp, there we go. So we're going to take the value of, this will become between the distance of, so what I'm trying to do is I'm trying to get a percentage, or it's between 0 and 1, of how close it is to the within a range from 0 to length and separation. Not separation. Separation? Yeah, separation. Separation. So, and as this gets closer and closer to 100% or 1, then we're going to make this 1 minus this much right here. Yeah, so there we go. So as this gets closer to 1, it's going to make the velocity less and less and less. So let's see here. So I think that's kind of what I'm going to be doing for right here. I think that makes sense. So yeah. It's kind of like that. Let's see here. Let me see. That's kind of what I'm looking for. Except now that it does the same problem where it has like everything that's too far down. So let's try something a bit different. Let me think here. Let's see. So we can do it like that, or I can maybe have it closer to the position. So as it gets closer and closer. No, wait, no, I'm thinking about swinging right now, and that should be for the X. I'm thinking about being pulled down, so I gotta think about this separately, a bit differently. Oh, wait a minute, wait a minute, wait a minute. What if I do this? Okay, rope direction, separation based on the anchor position plus tether position. And we're gonna go ahead and make the tethered, not position, equals tethered body times, I don't know, tethered body velocity times time dot delta time. We're going to make this plus equal. So that should potentially move it. I like to move it, move it. You like to move it, move it. Oh my god, what am I thinking? Okay, so to the bottom position, so that might change the actual position first. Then it'll do some correcting here. Let's see here. And let's see here. And then we can just do maybe tethered body dot move to rope end. So we're going to go ahead and copy this one as well. Rope end 2. We're just going to do that for now. Or actually, no, I can just do this. Dot move to, move position. There we go. So get this position, rope position, or rope direction is based on that. So actually, no. What we got to do now is actually we got to move this up. I'm saying actually a lot. So apply some physics here, make it move. Then we calculate the rope direction, and then we set it here. And then we're just going to go ahead and return and see how that looks. Oops. Let's see here. This may be what I'm looking for. Okay. So, yes and no. Definitely not. So let's think about this here. could make it move to this position. Here, then let's see here, tethered body dot velocity. That's not quite what I'm looking for either then. Let's see here. Velocity equals vector 2 dot 0. We're just gonna set 0 for now. And that position equals right there. So there we go. So it applies the velocity, removes the velocity, and then doesn't let me do a thing. Should be moving though. That's what I'm trying to think. Should be letting me move. Or I guess we can just do times equal to right to get rid of the y velocity and keep the x velocity. So if I do this, there we go. Oh, that's interesting. Not quite what I think it needs to be. So how do we speed this up? It could be that it's taking so long because it's a physics update, and it's being calculated a lot less. So it's quite possible that it would work better if I put an update, which I'm pretty sure may fix it, but or if it does, maybe not the best fix. Yeah, didn't fix it. Didn't fix it at all. Cool. All right, I'm kind of glad in a way, because honestly, I didn't want to have to try to get to work if it only worked in update. Okay, so let's see here. Let's try another method. Or let me see here. If I do 9.8, move it down by 9.8 meters per second, then alright, here's what I'm gonna try to do. We're gonna try something. If I make this kinamic, and if I try to make it, I'm gonna try to simulate gravity real quick first. Let's see here. Tethered body, dot velocity. Oh, I don't think even velocity would matter to it. Well, we'll just try this. Vector 2 dot down, or actually let's do up times physics 2D dot gravity. Let's see if there's anything here I can use for what I was trying to do earlier. Oh, simulate. Might want to look into that. I'll look into that in a second. First, let me do what I actually came here to do, gravity. And that should not move it at all, if I'm not mistaken. But hopefully it does, but I doubt it. Oh, it does. Sweet. Okay. Because, let's see here. Because now without that, it should stay completely still, right? Okay, cool. Let's see here. So that's kind of what I'm trying to do. Or what I can potentially do is this. Let's see here. Plus equal. Let's try to see right here. To simulate if it's simulate as it speeds up as falling down, what I'm going to do is vector up times physics. Let's see here. So, trying to think here. We're going to do a math f the inverse lerp. Make the first value 0 and the next value, let's see here, math f the absolute value of physics that gravity. Okay, and we're going to get the absolute value of the velocity y. Okay, here, there's that. Um, okay. So what this is going to do is that's going to calculate how fast the velocity is compared to the gravity. So as it starts at 0, so this would also be 0. So then we would also want to see. I want to say acceleration. Oh, actually, I think I use the acceleration formula, right? Acceleration. What's acceleration formula? Acceleration formula. Acceleration. No, I don't need a video. I want to read. Just let me read here. Acceleration equals final velocity times initial minus initial velocity over time and change in velocity. How quickly the velocity of an object changes, so the acceleration is the change in velocity. Okay, so then if I want to, let's see, I'm trying to think right here. Times time equals. Okay, here's the idea. Okay, so the acceleration is going to be gravity times the delta time, so it's going to keep adding onto that. So let's see here, we gotta get the gravity. So I'm gonna need to do a few things here. So let's go ahead and get physics 2D dot gravity times time dot delta time. So that's one part of it. Then what we're gonna do times 1 1 minus inverse slurp is 0 absolute value of gravity times absolute velocity. Math F dot let's see here. There. So it starts at 0. The initial velocity starts at 0, and as it gets closer and closer to the actual value, then it's going to do this. Or actually, let's see here. Actually, I think I can even do this. Make clear. If velocity, tether velocity dot y is greater than 0, or actually is greater than 0, is greater than physics.gravity dot y. So if it's moving up, or if it's moving faster, if it's moving up or it's not moving at all, gravity's going to pull it down. So I think I can simulate gravity just by doing this here. So let's try this again. And once it comes out, it's going to stay exactly the same. So 9.8 meters. Let's see here. But if it gets launched quicker than that, if it has faster than that, then that's okay. That's okay. Let's see here. What we're gonna do is then we're gonna go ahead and do math min. We're gonna go ahead and, or actually no, I can just clamp it. Clamp. Math clamp between two here. Here with the minimum value. Nope. Just do min. Min's easier because all I gotta do is this. Oh, fine. Oh, ooh, that's not gonna work. Damn. Okay, so let's see here. Oh, and then I can just do this instead. Vector 2 dot let's put this up times gravity y. So as we're adding to it, oh wait, no, that's not right either. That's definitely not right either. What we're going to go ahead and do instead is that we're just going to add a check here. Because I have no problem with the velocity being more than the gravity. Because, if it gets hit, that's okay. But if gravity is adding to the force, then we're going to change the velocity here equals dot y is less than gravity is less than physics.gravity. Physics.gravity.y, then tethered body dot velocity equals physics gravity. So there we go. So that should simulate some physics, but it's probably gonna fall through the floor, yeah. Let's see here. if physics 2D that collide let's see here. So I can move through things because of this. What if I do this? Will that make it move too? Pretty sure it won't. Let's see here, because I want it to move down. Alright, here's what I'm going to try to do. Every time fix update, we're going to set the velocity to 0, I guess, equals vector 2.0. Ooh, I don't think I like that, but I just want to test something. That's funny. Okay. Not quite. If I do this, I think I effectively doubled the gravity by doing this. Because if I don't do this and just return, oh, this is getting really annoying. This is getting really tiring. Yeah, so basically I just doubled the gravity, because if I were to edit product settings, physics 2D, if I times that by 2, yeah, I'll congratulate myself. I've effectively double gravity with my script, so I should be able to simulate gravity, I guess. But just at the collisions, that's the problem. I don't want to have to calculate the physics, but I think I'm going to need to. Okay. Let's try this then. Oh, whoops, I meant to do, try this. I think actually that might be it. No, damn. Oh, I think also I need to do this. Let's see, try this now. No, that's probably for the best. Spending a lot of time on this one little thing. Let's see here. What's the point of this? What am I trying to do? I want to be able to swing. I could make an animation, I guess. Oh boy, starting to get tired. Not sure what I want to do with this. Okay. Okay. What's the idea? I need to implement a rope type feature, and this is not a rope type feature. Where are we at? You know, I just really just wanted to test a theory I had. I tested it, didn't work. It's kind of late. Oh, and there's no audio, was there? There was. I don't think there's any audio when I did that for a while. Oh my god! Don't tell me. Let me try this. Um, can I still be heard? Yes, I could be heard. Never mind. I'm good. All right. So with that being the case, I'm getting really discouraged here. So either I need to work something else, or I'm gonna stop streaming. Well, give me a second. Let's see here. Let me just clean up my browsers real quick. Let's see here. Should we go ahead and do this for now? Okay, you know we're gonna try. We're gonna persevere. We're gonna try something else. This is definitely not working for now. So we're gonna try to do something more interesting. So that way I can at least get the creative juices flowing. So let's go ahead and try that again. Let's try something else. Here, okay. Next thing, what be more interesting to do? Let's see here. Oh, maybe actually no. Maybe if I change the velocity. No. So I'm trying to say it's taking it to Kinamic and then trying to encode custom rope physics when it's connected. That just doesn't sound like something I want to do right now because I'm too tired. Uh, maybe if I can try to, let's try something else. What I can do is this. I'm feeling like trying some pixel art. So let's let that load. I might change a few things. What my streaming is. Ustream.io. Okay, titles. Let me go ahead and let's see. Give me a second. Thank you, Billy Buttons. No, Billy Buxton 101 for the follow. Um, personally right now, I'm trying to think about what I'm want to do. I've been struggling with this rope physics for forever now. It feels since earlier today. So I'm kind of thinking if I just want to go and just probably play with some pixel art and maybe beautify this game up a little bit because it's it's really getting a struggle, you know. But no, I want it to work. I should get it to work. Or do I need a rope at all? Because I could, and this would make it a little bit easier. I would think I can implement it. I could use it as something when you get tethered to it, it just launches you in the direction of the rope. Excuse me, but no, that's probably not what I'm looking for. Let's see here. Let me think here. If I really want the rope, then I need to do a few things. I'm going to completely get rid of most of my code. Potentially, I'll keep some of that code because I think that would help here. That I don't see why I would need to get rid of it. I can try the circle line formula for a circle later again, potentially. Here. Okay. So I'm gonna need to do a few things every fixed update. I need it to account for gravity. Account for swing. So I need to account for gravity, account for swing, so that way when the player is just swinging and hanging there, or if they move, they keep their velocity going the other way. Okay. And what else do I need to do? Account for swing. Eventually, I would need to have a way to let go. Implement let go and implement a grab or throw. Alright, so let's see here. I could potentially just look up to see how other people wrote physics, but I kind of looked up that a little bit, and a lot of other people were having trouble as well with that. So, if anything, wait a minute. Maybe. Ooh, I have a kind of almost a cheaty way in a way. Actually, oh, wait a minute. I just realized something too that I completely forgot that Unity might have, which would make my life so much easier if it did. I think it has the joints. And it does, and oh my god, I spent 5 to 7 hours, prox give or take, and I completely forgot to look into any kind of joints. Spring joints, oh my. I'm gonna cry. Uh, so let's try this. Let's try to think. Let's try to think what joints we need. Oh my gosh, a distance joint. That's what I would need for sure. Anchor, connected anchor. Oh my god, you gotta be kidding me. The local space from an anchor from the connected rigid body. From the anchor to the connected bodies. So this would be negative. I'm actually not sure. Let's see, distance joint. Break force, so it's gonna take some time to break from it. Distance. or maximum distance which the joint should attempt to maintain between the two bodies. Oh my god, there was something already there that I could have used potentially. Um, oops. I need to move the player up 3, and then alright, so this rope is not gonna need a script. It's just basically gonna be the actual I don't know, let's see here. Okay, we're gonna do this. We're gonna put this into here. It's just gonna be a graphic. And what we're gonna go ahead and do is add the joint to it. So let's go ahead and make this line renderer's position a little less. Oh, I don't know. My foot just started hurting. That's weird. 1.25. That's actually supposed to be 4, so 1.15 would be 3, and that's not what I meant to change. I'm going to change this. 1, 2, 3. Perfect. 5. Man, sometimes I really get confused about what, I don't know, adding. Oh, actually, no, let's see. So adding negative numbers. So negative 0.5 plus 1 equals 0.5. Okay, 0.5 plus 1 is 1.5, and then plus 1 is 2.5. Okay, that's what I kept getting the problem is I kept skipping 1. Oops, total tangent, ignore me. But there's that as well. Where am I at? Okay, I just want to pull up a few things over here to make sure everything's working good. Looking good. Okay, so there's that. So if I go over to here, connected anchor would be so 0, 0, and 0.5, and negative 0.5, and that'll be the distance of 3. Whether maintain a maximum distance or only not. If not, then the absolute distance will be maintained instead. Maintain maximum distance only or not. If not, the absolute distance will be maintained instead. Yeah, that would be probably preferable. Connected rigid body would be the player. And we're going to go ahead and actually make the player back to dynamic. Go ahead and go here again, and so this is the everybody connects to the same. The rigid body to connect to. Connected with a disjoint collide. Sure, we can have them collide. And let's see here. Why is that the way? If I had to guess, that's because this white tile, if I open the sprite editor, that's not it. I'm not quite sure why it's doing that. Oh, I see. I'm offsetting. There we go. Don't need to do that. Okay. So if I do this now, I'm gonna be seriously so mad if okay. There's that. And this rigid body actually needs to be static. Oh my god, I spent... Well, okay. It's not perfect. It's definitely similar to what I have already. Okay, phew. That means that it's not as easy as I thought. Let's see, extra bigger distance. Afraid to make the joint unbreakable. Um, so for this, we're gonna go ahead and actually add back the rope script, and we're gonna just change it up, so that way it gets complete rid of all this malarkey. And we got the line renderer, we got that part. We also need another thing here. We're gonna do this here. We're gonna put this into update because we're not using it anymore. What we're gonna be using this for is, shoot, I have to do this. Line renderer rope equals nothing because we don't need it to do equal anything. And then we have to get the hinge joint 2D. Make it public hinge joint 2D rope anchor or rope hinge. We're just gonna do rope hinge. There we go. And so what that's gonna do is that we're gonna get the tethered rope hinge dot anchor. All right. Actually, we gotta swip this around. Rope hinge dot whatever it's tethered to. Did they use the word tether? We'll see. Use the motors. Anchor. Attached rigid body. Dot position. After this. Anchor. Anchor. Rope. Length. Distance. What's the thing called? Distance, yeah. And rope hinge, not distance. What I can just do then instead is times it by the separation instead. Wait, what am I trying to do? Oh, whoops. I see what the problem is. What I'm trying to do is this. And this would be rope anchor. Vector 2. Let's move this around the other way. Vector 3 and vector 2. So I could just probably cast it to vector 3, right? Vector 3. I don't think I should be able to. But I'll hope. Sweet. Okay. We're just gonna make this a separation length. Separation. Set positions. Actually, the second position needs to be the rope hinge attached rigid body position. And this also needs to be the attached rigid body position. Add a Y. Y. I messed up at. Okay. Direction equals rigid body position minus. Oh. Here. Not sure if this is what I actually want. I think I would want it to be this one first, and minus the attached body normalize. Okay, rope direction. There we go. Draw the line. Draw a hinged anchor, and we'll just do. Victor 3. Sure. That should be. Oh no! Don't play. Don't play. Don't play. Oh wait! Don't tell me. Oh, I'm using a distance joint. Okay. You know what else? What other joints do we have here? Character joint, hinge joint. What about this hinge joint? We're gonna go ahead and just disable this one for a second. We're going to have this connected to the player. And connected anchor is going to be 3 down. Angle limits, the lower angle. No, Google, I'm not talking to you. You know what you did. Yeah, that's exactly what I'm talking about now. Alright, so now I want to change the angles. I'm hoping that Gizmo would I was hoping that Gizmo would update along so I could see about what it decides to show me, but it doesn't look like it. And also this would be -3. If I do this -3, oh, okay, that's not what I want. Let's see here. There we go. That's what was the problem. I knew I should have upgraded. We're gonna set this to 0 and this one to be 180. And we'll just see how that turns out. Because why not? Because you know, if it's probably gonna be working a lot easier and better than what I thought to use. Ooh, see here. Not quite. Three 359. Alright. don't understand why that's not moving. Hmm. That's cool. Always wanted to be able to make gizmos like that. That'd be kind of cool. But I'm not really sure why it's not moving at all. This is because this one is static. We could try making it kinetic. See how that fares. Okay, I think I've figured out why. Let's try this. Let's see here. So, yeah, I was right. But then, what does it mean when it says connected rigid body right here? Player is dynamic. So it's spinning. That's cool. But that's not quite what we're looking for. I'm trying to think, what was this rigid body for? Okay, no rigid body connects to the scene. Enable collision? I think so. Let's think here. What? It's probably not it either. Okay. Relative joint. Spring joint might kind of work. You know, we're gonna finish this and say joint 2D. So we got the wheel joint, a target joint, a relative joint, hinge joint, friction joint, and a fixed joint, distance joint. So, what does this mean? Slider joint, kind of. I'm looking for a wheel joint. Alright, let's take a look at the target joint. Let's see here. See, edit joint angular limits. This is the hinge joint right here again. Anchor. So basically, I assume that it's already attached to this current one. Here, auto configure target. Seems to be there. And oh, maybe it's jointed to this target. Doesn't make much sense. Dynamic. All right, cool. So if I were to move the hook, it would move the joint along with it, which seems right. Seems about right. Hmm. Let's move this anchor up a bit. What? Okay. What's going on? Okay, so let's go ahead and just make this dynamic for now. Target joint. Anchor. The locus base anchor on the rigid body the joint is attached to. The local space and the world space that the joint should move the rigid body towards. How about we try putting this particular one into the player. And we're going to add in the target joint. The target is going to be position of this hook is 0.5, 2.5, 0.5, 2.5. Auto configure target. No, 2.5. I thought I got rid of that. 2.5. And we'll see how that looks. Alright, we're gonna make the hook again static. The player like this here. Or let's auto configure so it's there. And the anchor is going to be 2.5 up. So if I do this now, kind of what I'm looking for, I think. So if I move it like up here, I think that's a bit too much. 1. And let's make this 2. Or what if I make this 0? Then no, that's with the target joint. The target joint's right there. Huh. I feel like I could use this. Target joint is definitely something I could be using. Yeah, and then I can like make it if I want to have the thing follow my mouse. I can dampen ratio, frequency, brake force. Like, get away from me! Alright, that's cool. I wonder if I do that, does that add velocity to it? So let's see here. Come on. There you go. If I do this, or oh shoot. I don't know what I did. Is that not how it works? I'm so confused. Then how was I making it fall on my mouse? That's so weird. Oh wait, I see the problem. I see I'm not in play mode. Potentially that's the problem. We'll see, hopefully. What I had last time was this, so I can just grab this. So hmm. Interesting. How about this? I can tell what is going on if I look at the inspector now and look at the player. Oh, okay. Hmm. Okay, I moved the wrong thing. That's what it is. I grabbed the wrong thing first. Let's make this anchor 0 and 0. And the target is what I'm trying to grab onto. There you go. Yeah, so this target should be here. Interesting. So very interesting. So can I use this to implement a rope in the way? Can't. I don't think that's what it is. Okay, I don't think I can do that using that particular one. A wheel joint, eh? To rigid body. Let's do player. And suspension, motor. Actually, I think this one should go in the other one. Move component. Okay. Okay, probably not. There we go. Let's add a wheel joint. Okay, so now he's got to move the player over here. And let's see here. What else? I think that's about it. It's auto configured, so we'll just go ahead and play mode and see what happens. Interesting. So just move the player down. Oops. Move the player over here. Ah, okay, I see. So that way, if player moves, or no, motor, it's going to be spinning forward here. Player, or actually no, it's not going to be necessarily this part. It's going to be the hook itself that's spinning. So dynamic. Yeah, there you go. So that would be like a wheel. Oh, so that's kind of cool. I can make a 2D car like that, or a 3D car, or 2.5D car maybe. Let's go ahead and increase this motor speed. Vroom, vroom. There we go. Okay. So that's cool and all. But can I do that? Maybe let's see here. What? Maybe actually maybe that one had potential. Because what if we instead right here get rid of this wheel joint here, remove the line and a hook, and add that wheel joint to the actual rope itself, and then we're gonna go ahead and let's see here. 0. What's this part right here? Is this where the joint's gonna be at? So actually, this doesn't have that doesn't have a 2D body, does it? Oh, it does now. Actually, I don't think it does, but we'll see. Oh yeah, it does now. Okay, so now if I go here, we increase the motor speed for this particular one and use motor. Okay, so if this was if we added a let's see, collider. I could add edge collider, I guess, or a box collider. And if we made it, let's see, this made us 3 and then made this like 0.25. We would see that out, but then we would, oops, I seem to have launched the player. We'll just make it a trigger. It's trigger so that it can move around as happily as it wants. And also, if we offset it a little bit, we have to offset it by offset. We have to offset it over here by let's see, 1.5 negative. Point. Not negative. Actually, let's do this 1, 1 again, and then we got to make this one 0.25, and we're gonna make this one 3, and we're gonna make the offset 0, and we're gonna make this offset 0, but we're also gonna add 2.75. Minus 1 minus 0.75. So then we want to add maybe 0.25. So yeah, that's interesting. Okay, that thing is a little off center. Motor speed, angle, dampening. Let's see here. Alright, let's go ahead and try this again. We're going to add a box collider. 1.5? Yeah, that seems about right. And now we go to look at the hinge joint. Okay, because that, yeah, that's probably kind of what I'm looking for right here. And I can keep that swinging. So then what if, let's go ahead and make this a trigger. And then what if we added a position joint or a target joint? Yeah, a target joint there, so that way it would be falling. Okay, here's what we're gonna do. Then we're gonna add a target joint here. Target joint 2D. I think that's not right. Component. And what I'm going to go ahead and do is add a to this one a target joint 2D, and the target's going to always be the end of this one right here. So let's go ahead and add a empty here. Create empty, and we're going to move this towards the end right here. So if I went ahead and press start for a second, the empty, I don't think the empty is going to move, right? And then you want no. So if I just did okay, so that's the position, the rotation. So I would need it to do a few things here. So maybe then I can add a target joint at the end right here. Once I get it to follow, then I can just hook the player into that, and so that would always follow the end, and have a little dampening delay, like if they're being swung on the vine, which is I think the effect that I'm looking for. Actually, I think I'm gonna have it. I think this might work. Okay. So we need to make a rope script here, and we're gonna need the wheel, and we're going to need a box collider, and a target joint. So we're gonna need a wheel joint 2D, a wheel joint, and then we're gonna need a public target joint 2D. Target joint. And then we're gonna have a public transform hold position, and there we go. That should be it. And we're just gonna go ahead and get rid of all this because we don't need it anymore. Because I figured out have another more promising site. So this is gonna be the hold transition. This is going to be the have the target joint, and this is going to have the wheel joint. So there we go. So there's that. Okay, so first step is to have the transform move with the position. So, curious if I were to change the rotation on this, would that do anything here for me? No, it would not. What I can do then is every fixed update or every update? We'll do this. Every fixed update, we're going to have the hold position dot position equals I need the box of the box collider. Public box collider 2D and rope collider. Sure, box collider 2D. And this is going to equal box collider position local attach for each body position or local position. Local position equals position. That's not going to be quite right, but it's a step in the right direction, I think. So now we have to just move this over here too. There we go. And let's go ahead and do that. We're going to actually use the motor again and check to see what the game magic's at. It's going to actually just be the transform world. So that transfers a point from world space into local space. Hold position transform that is a local space to transform position from local space to world position. Trying to think here. Vector 3 translation, so I'm going to go ahead and translate vector 3 dot down times 3 relative to transform. So that, I think that would be more what I'm looking for. So now it should be moving, if I'm not mistaken how this works. I'm trying to think right now. translate down a bit. Yeah, kind of what I want, but not quite. I don't want it to keep moving. Really well, we have on our team. Transform direction. At the axis through the point in which it will coordinate by angle of degrees. Rotate around. Okay, here's what I'll do actually. If I do this, I first need to do equals transform form position. And I forgot to make it spin. I gotta make it. I want to make it spin by default. There we go. Yeah. Alright, so first things first, I gotta make a this spin by default. And then we gotta do this target joint dot target equals hold position dot position. And I think that should do it. Let's see, let's turn the motor up. Heh. Slowing down, it's like whoosh. And now I should just always keep spinning forever, right? Hmm. Hmm. Oh, okay. Uh, let's try this. Angle, frequency, damping ratio, connected anchor. Huh. I never thought about that. Why? Yeah. So 158. 2, 2. Hmm. Okay, so there's that. It's kind of right. Now we just need to stay at the correct angle. Oh, huh. Trying to think right now. So this is similar, but I don't. Maybe a wheel joint's not exactly what I want because it's not getting affected by gravity by the way that the other ones would. Let's see here. All right, and then we have this hook. Oh, we don't need this here. I don't know if that fixed it or not. Probably not. Hmm. How to configure distance, max distance only. Let's just go ahead and disable this wheel joint for now. Oof, it fell down. Which is okay actually, because then I'll see this. Hmm. So maybe I could make my Y go up when I can't move X anymore. There's a lot, man. There's so many joints. I'm trying to think how to get them to work together right. Joint 2D. All right, friction joint. No, relative joint. Maybe. Let's see here. A relative joint compared to what? That's what. Uh, move component. I'm just gonna go ahead and disable that for now. Disable the rope. Wait a minute. Yeah, that just shouldn't have done anything, so we should be good. Hook. Am I looking for a hook? Give me a second here. Alright, so there's that. Here. Alright, so now what other joint do we have to play with here? Relative joint. Ooh, I thought I felt an earthquake, but guess not. That was actually, no, that was my kitty. That, okay. She's the one who made it. Do that. Okay, so what does this relative joint do? Let's go ahead and put this down. And hello, kitty. Are you gonna come lay in my lap? Oh, you tired. Let's see here. Let's see here. Time is it 1:01 in the morning? Yeah, that's when everybody's awake, right? Definitely. Definitely not only one awake. Oh, kitty, what are you doing? You're so cool. Let's try this. Alright, so movement's not going to work. Oh. Brake force, torque, auto configure it, correction scale. What if I do this? Do that. Max force. Oh, whoops. So now I can move again. So. Huh. That's kind of funny. I don't know if it's just me. Alright, let's see if I change this to 100. Okay, here's that. Looking into hook again. Okay. Well, this is similar to what I wanted. I took the relative joint off. Hmm. Whew, my voice is getting tired. I guess I'm getting tired of talking too. I guess what I'll go ahead and do is I will turn on some music for now. Oh, that's not what I'm trying to do. There we go. Hmm. Alright, that's definitely more in tune to how the rope is supposed to work. The only thing though is that it doesn't have a swing. I wonder if I can. Is there some way I can fix that? Maybe I had a different one, two of them at the same time. Hmm. We'll see. Marco de Hongo. Marco. I don't know. That sounds. I like this music. Cause then I can imagine making the thing goes swinging. Hmm. Ooh, ooh, ooh. What if? Ooh, ooh, ah, ah. If I take off the relative joint and take off the distance, put it on the distance joint again. Turn it on, and then what I'm gonna do, go ahead and do, so I can move around. I'm gonna add one more thing, one more kind of joint to it, a spring joint. Haven't played with that one yet, but my idea is I'm gonna have it kind of slightly pulling towards it constantly, so that way there should always be some room for it to fall down correctly. Or maybe I don't need that. Maybe I just need the spring. Huh. Let's put this distance joint back on. And we're gonna move the anchor up just a little bit. Okay, I can set this to 0. And we can set this to 1. Okay. And so if we do this, maybe 0.5, change frequency to 10. Okay, why you gotta sneeze like that? 2. Oh, huh. It breaks, it goes away. Kind of what I want. Let's see if I turn the rope script back on again, and then make it so Christoph Lamb 1, Kappa, Kappa to you as well, Kappa. What you do? Oh man, I'm so sorry. I didn't see see talk. Hopefully didn't. Yeah, I have a bot, so that does that. So that's one of the things I could say. I am currently working, playing with Unity, looking through the joints, because I am trying to figure out a way to implement kind of rope physics, so that way they can swing. And as you can see, I'm thinking I'm kind of stumbling onto something that I might like. My thoughts were, give me a second here, let's go ahead and do this for you so I can see it. My thoughts were that if I could have a spring pull me up a little bit, so that way I could always fall down, because when I'm too far away, it just completely destroys my descent, which is not really what I want to happen. I want it to be able to swing, you know, go down and it just goes whew, kind of like this. So I'm kind of trying to. First I tried to code some kind of way to keep be in the right position. Then I kind of figured, wait a minute, there's joints. Maybe I can use some kind of combination of joints to do what I'm trying to. If you have coding experience, I'll help appreciate it at this point. It's getting slow, so I was turning some music on because I was getting tired because it's 1 a.m. in the morning. And yeah, but enjoying life. What are you doing, man? My man. Oh, I get it. Oh, I was supposed to be my man, but I'm assuming that's what you're trying to type anyway. Excuse me if I'm a little frazzled. Kind of tired, I guess. Okay, so my second thought here was to let's get rid of the spring force. Move component. Let's remove the hinge. Move the wheel joint and relative joint doesn't seem quite right. Okay, and I'm gonna add a skip the rope, skip this rope here, and target joint in hold position. This probably doesn't have what I need anymore. Wheel joint, don't need. Target joint, box collider, probably don't need. Let's see here. This is a new thing I'm trying to do. Let's look at the script. Let's just look at the script and see what we need. Let's get rid of these, and we'll just have a joint 2D. Bam. Root. joint. What's it called? Root joint. We don't need this right quite yet or anymore. Well, we might for later. And root joint dot target the hold position. No, that's not what I'm looking for. Oh yeah, I do need a target joint. That's right, I do need a target joint. So we're gonna go ahead and just duplicate this, put this name here, and we're going to do this target joint 2D. And ideally, this would be a little bit above the offset. So let's go ahead and have a vector through here. Actually, then if that's the case, we don't need this transform here. Well, it would be easier to kind of visualize it. If you hear screen in the background, just ignore it. It's funny. But probably don't need this right now. But I'll keep it. I'll keep it. Because then I'll use it for the second. Public vector 2 probably would be what I want. And hold offset. Alright, there we go, there's that. So then I would just need to translate the hold offset by and the transform. Perfect. Root joint dot transform. And target joint hold position equal. There we go. That should be what I'm kind of looking for. Let's go ahead and update. And we're gonna have the root joint is going to be this hook's distance joint, and we have the target joint be this player's. Oops, that's not what I meant to do. This player's target joint hold position, and we're just going to create a quick empty inside here. And we're going to go ahead and move this over to here. Hold offset, we're going to set this to 2.5. And the player's transform, we might want to enable that. That'd be a good idea. Let's see how this looks. Huh. Interesting. It's remembered because I need to make the offset negative. Perfect. Okay, so the problem is now that the target's stuck right here. So I need it now. I need it to move. I need to move with the joint, not the not that. So let's see here. I need it to move with the joints based on the joint itself. Equals, and based on the root to transform. Alright, I'll just turn that off for now. Let's see here. Hold that transformed up position. Oh, my kitty's just laying in my lap, licking herself. Like cats be do. Be do. Where should I go for this? Target joint. Hold that position. It's kind of what I'm looking for, but the only problem with this is that the actual joint doesn't rotate, because this transform doesn't rotate either. Let's look at this target. That's the same, because this one is always staying the same as well. We need to move along with it. Okay. So, in that case, I could potentially set it up to the rope. The target moves with the rope, and the rope moves with the player. Oh, Kitty, what are you doing? Oh, no, calm down. Or I could set it to be offset it a little bit for the player instead, or the target. Commentary gets harder. We're gonna make this offset. This root joint is not needed anymore. Target joint is needed. We'll offset from let's see, target joint. No, target joint. Oh, I see. Copy target joint dot game object. No, transform. Okay. Hold target joint target equals hold position dot position. So now if we do this, if we change this to something like 0.5, try that again. Oh, I know. Oh, I know why. I know why. Because in the script itself, we set the position to the wrong transform initially. So here we go. Alright, so now that should do it. Huh. Yeah, that's moving the target up way too fast, or unnecessary. Let me see here. I can make it so in the distance. Oh, come on, man. Okay. I think we're done for tonight. Or the morning. I'm hungry, tired, and not feeling that great right now. So, I hope you enjoyed watching. For the people who joined, me struggle. I definitely want to look into this. I want to figure out something. But that'll be for another time. So yeah, I'm just going to go ahead and let's see here, where is it at? Pretzels. I'll go and music go for me. Alright, well, see you guys the next time. Bye bye.